Welcome to Summarize Science. Have you ever seen videos of those four-legged robots and wondered how they run and jump so effectively? Making robots move like animals is incredibly difficult, but new research shows how inspiration from nature can lead to amazingly simple and effective solutions. Researchers at Florida State University developed a control system for quadruped robots that is both stable and robust. Instead of dealing with the complex dynamics of a full robot, they simplified the problem immensely. They modeled the entire robot as a single point of mass on a springy leg, an idea known as the Spring-loaded Inverted Pendulum, or SLIP model. This concept is directly inspired by running animals, whose bouncing movements can be boiled down to this simple spring mass system. A running robot's movement can be broken down into two main phases, a flight phase where it's airborne and a stance phase where the leg is on the ground. During stance, the leg compresses like a spring, storing energy, and then releases that energy to push the robot back into the air. The core idea behind this new controller is to manage this energy exchange perfectly. The controller works by calculating a perfect bouncing path or trajectory for the robot to follow during the stance phase. This path is based on the principle of energy conservation, ensuring that just the right amount of energy is used to maintain a stable, repeating bounce. Essentially, it tells the robot exactly how to extend its leg to keep bouncing at a consistent height and speed. To test their idea, the team ran simulations using the design parameters of a real-world robot, the Ghost Robotics mini-tour. The results were fantastic, showing a perfectly stable and repeatable bouncing motion. You can see here in the phase plot that the robot follows the exact same loop for every single hop, indicating a highly stable gait. But here's the most impressive part. The controller is incredibly robust to noise. In the real world, sensors aren't perfect and can give slightly wrong information. The researchers tested this by feeding the controller sensor data that was off by up to 10%. As you can see in these plots, even when the robot thought it was in a slightly different position, the controller was able to quickly cancel out the error and get back on the perfect trajectory before the next hop. So let's recap the key points. The researchers used a simple, bio-inspired model of a bouncing spring to represent a complex quadruped robot. They then created a controller based on energy conservation to achieve a stable running gait. Most importantly, they demonstrated that this controller is robust enough to handle the noisy sensor data you'd expect in the real world. This work is a significant step towards creating more agile, efficient, and reliable legged robots that don't need massive computers to perform basic movements. Future work will involve expanding this to 3D motion and, of course, testing it on a physical robot. Thanks for watching this episode of Summarize Science.